Today is lesson 5-2, positive and negative intervals of polynomials. That's how Mr. Sindel sings, and that is our random event for the day. Today's date is... What? Today's date is Wednesday, November 13th, 2019. Is there a student that can sing the objective? He laughed musically.
Will you take our participation card?
Yes.
I don't really feel like that.
Yes, Anna.
Determine whether the is above or below the x-axis for a specific interval.
Thank you. Our game warden is doing an excellent job of logging that 50 XP.
I lost the iPad.
That is not good. All right, our strategy for the day is knowing that a polynomial can only switch between a positive and a negative height by going through the what? It's the thing that you found yesterday.
Mr. Sindel, something came in the mail today.
India, what is it? It is the x-axis. It is indeed. This is interesting because since we only have x-intercepts, that means if I am positive here, I am also positive here and here and here and here. I can only be negative after going through an x-intercept. I might still be positive, but I could also now be negative after moving through the x-axis. So all we need to do is to plug in how many test values between each of those things that we found. Because the sign won't change, so you only need to plug in. That's it. One test value. Just by plugging in one test value, you know the sign for the entire interval. So plug in one test value in between each x. Is there a quiet raised hand? Who can sing the answer? Leo. Oh, okay, sure. Between each x, you guys know the word. Anna, it is.
Axis. Oh, interval.
Close, but it's intercept. You still get your delicious 50 XP. Now that we know our strategy, we must find our procedure. After finding the x-intercepts from the last lesson, you must first plot the things that you just found, which are called what, with a quiet raised hand. Lorea, please sing the answer. Close, it's this word right here. It is indeed intercepts. First, graph your x-intercepts on a number line. Then we go on to our final step of plugging in the... We've said this word before, we'll say it again. It's down in here in the bottom paragraph. The first word starts with T. The second word starts with V. The word is right here, and multiple other places. It is the test value. I am going to make this a plural word because there are multiple intervals to plug into. But there is a shortcut. You will have to figure out the shortcut on your own. Let's move on to example number 1. There is our factored polynomial. It has zeros at -2, 0, 1, and 5 halves. Let's do step 1. We will make an x-axis. Down here is a good spot. Notice that it always gives you x-intercepts in the correct order. So my first x-intercept is at -2, -2, 0, 1, and 5 halves. Hooray! We have done the first procedure. I believe the custodians use vacuums. Colby, if you wouldn't mind shutting your laptop, please. Thank you. We are on to step number 2. Mr. Sandell will do the first step for you. That rhymed. First, I will plug in a test point over here. What is a number that is less than -2? Is there a quiet raised hand? What test point should we plug in? Oh dear God. Not anyone knows a number less than -2. So far, the Warners and India are all that have participated. I need someone new. Oscar, please sing a number that is less than -2. Precisely, -3. Let's check what happens when we plug in -3. We only care about the sign. Is it positive or negative? When I plug in -3 into x, is it positive or negative? Everyone will do this together. Is it positive? Thumbs up. Negative? Thumbs down. When I plug in -3 into x, is it positive or is it negative? Oh dear God, it is a negative. You guys, -3 is negative. It is okay, we will get the next one. We have a negative. I will write it like this. Let's try it again. I'm plugging in -3 into 2x minus 5. 2 times -3 is -6. -6 minus 5. Is that a positive or a negative? Show me with your thumbs. Sam, hood off. It is indeed a negative. Next we have -3 being plugged into x plus 2. Is that a positive or a negative? No. It is a negative again. And our final question is a trick question. When I plug in a -3 into a x minus 1 squared, do I have a positive or a negative? Ooh, he exclaimed musically. Everyone got it right. It is a positive. Anything squared is always positive. Anything to an even number is always positive. Negative to an even power is positive. You might want to write that down. My final question for you is a negative times a negative times a negative times a positive is what? Negative times a negative is a positive. So this positive times a negative is a negative. And a negative times a positive is a negative. So our final answer is that this interval is negative. Let's try it one more time before I let you begin. Let's choose a number in between -2 and 0. You need to sing that. What is a number in between -2 and 0? India, hold up your board for the class to see. Oh, -1. So now we can come back with our original equation. -1 plugged into x is a positive or a negative. Show me your thumbs, up or down. It is a negative. -1 times 2 minus 5, is that a negative or a positive? Negative, because a -2 minus 5 is -7. This is a negative. What about a -1 times a -1 plus 2? Is that a negative or a positive? Oh no. 4 people are participating, which means 8 are not. It is a positive, because 2 minus 1 is a positive 1. And notice that this last term will always be positive. Now my question for you is this interval between -2 and 0 positive or negative? Three people have participated out of a classroom of 13. It is a positive, because a negative times a negative is a positive. These two negatives are positive, so positives all the way. This interval is positive, and you need to do this 3 more times, yes?
Do we just plug in the -2, 0, and 1 to the x everywhere?
You do not plug in these numbers here. You plug in the numbers in between those numbers every single time. Sometimes this will mean you have to plug in a fraction. You can never plug in these numbers, because if you do, your answer will be 0, which is neither positive nor negative. Every single time, plug in a number in between this interval as a test value. What is another good test value to plug in? 1. Another good test value to plug in. This one is hard, because 5/2 is the same thing as 2.5, which means you are plugging in 2.1 or something like that. And don't forget your last test point, which can be something like 3. I will be circling around the room, looking to see if you can find all of these intervals correctly. There is a shortcut that you should be looking for, and it's basically listed right here. Good luck! Since we last recorded, we noticed that I had an error. My x-intercept should have been 1. Next, I will check my test point of 2. When I plug in 2, I get a positive 2, which is a positive. When I plug in 2, I get 4 minus 5, which is a negative 1, so this is a negative. 2 plus 2 is a positive 4, and the last one will always be positive, which means our interval is negative. Finally, when I plug in 3, I become a positive. Let me get rid of this. When I plug in a positive 3, I get a positive 3. 3 times 2 is 6. 6 minus 5 is positive. So I have a positive times a positive times a positive times a positive. And that is a positive. So now I have my intervals, and notice that it is asking 0 to 5/2, 0 to 5/2. What are the signs? The signs are always negative. The correct answer is B. Let's try another, slightly harder problem. Notice that if I ever have an even power, then my answer must always be negative or positive. Anything to an even power is always, always, always positive. However, these are odd powers. Odd powers you have to check. 1 is odd, 3 is also odd, so I only need to check these 2. That's it. That is kind of the shortcut. So again, we make our number line. Our x-intercepts are listed. -5 I circle. -8/3 I circle. +2 I circle. And +7/2 I circle. From there, I need to find test points. Notice that 8/3 is the same thing as 2.6 repeating. If you don't know that, I highly recommend learning how to convert fractions into mixed fractions. 8/3 is the same thing as 6/3 and 2/3, which is 2 and 2/3 or 2.6 repeating. So I choose my test points. My test points, I think -6 works fine. I could have chosen -10 or -1,000. Next, I need to choose a point between -2.6 and -6, so I will choose -3. A number in between -2.6 and 2 is 0. A number in between 2 and 7/2, which is 3.5, is 3. Again, we only need to plug in these test values into these 2 factors. From there, I will plug in -6. -6, when plugged in here, -6 minus 2 is a negative. -6 plus 5 is a negative. Negative times a negative is a positive. This is positive. When I plug in -3, -3 minus 2 is a negative. -3 plus 5 is a positive. A negative times a positive is a negative. Next we have 0. Let's plug in 0. Plugging in 0 to x minus 2 is a negative. 0 plus 5 is a positive. A negative times a positive is a negative. Second to last, we have 3. When I plug in 3, I get 3 minus 2, which is a positive 1. 3 plus 5 is a positive 8. All of these are positive, which means our answer is positive and positive. We don't even need to plug in a number over here like 4 because our numbers are so large. Let's look at the question. The question is asking between -8/3 and 7/2. Between -8/3 and 7/2. These 2 signs right here and here, what are they? They switch. It is sometimes positive and sometimes negative for our final answer of C. And we are not done because I want to show you the shortcut. Did anyone figure out the shortcut before I begin? The shortcut. You only need to plug in 1 test value because we know that the sign will change if the power is odd. And the sign will not change if the power is even. For example, if I come down here, this -2 has an odd power because it came from this linear factor. So I can say that has an odd multiplicity, which we will learn a little bit more tomorrow. It has an odd multiplicity. 0 is to the power of 1, which is an odd multiplicity. 1 was an even multiplicity because it had a power of 2. And finally, 5/2 came from 2x minus 5, which has an odd multiplicity. That means that the sign will change over -2 over 0 over 1 over 5/2, or not over 1, but only 5/2. Check it out. It flip-flops every single time, -2, 0, but it does not flip-flop over 1 because it has an even multiplicity. It stays negative and negative. To show you another example, let's look at example number 2. We have an even and an even multiplicity. That means -8/3 was even and 7/2 was even. -5 was odd and 2 was odd, which means you switch signs over -5 and 2. Over -5 we switch from a positive to a negative. Over 2 we switch from a negative to a positive. But over our even multiplicities, -8/3 and 7/2, -8/3 did not switch. 7/2 did not switch. There is your shortcut. And to leave you with something interesting, here is a graph of the first problem on Desmos. How is it possible that you can have a negative and a negative answer? Here is the graph.
Hey, what was that? Everybody gets what?
Notice that the x-intercepts here are exactly the same as in our problem, -2, 0, 1, and 2.5, but notice that the sign is negative, positive, negative, negative again because it touches and then returns to be negative, and then it crosses through the x-axis and continues on its way. That concludes this lesson.